Hi, what's going on, guys? My name is Brennan Babcock, and my topic for this poster presentation is the use of flavors of the Linux operating system in real-time systems. In this presentation, we're going to go over a few things. First and foremost is what a real-time system actually is, and then what constitutes Linux, the operating system itself. What are common Linux flavors in both common use and within the real-time system domain? What are the advantages and disadvantages of using Linux as a real-time OS? And what avenues of research and development what avenues of research and development for real-time application of a Linux system are being pursued? So the first slide, right here, is what is a real-time system? And put simply, it's a system that handles events as they occur, responding in a correct and timely manner. So for a real-time system, the accuracy of a system and the usefulness of it is not only judged by how correct it is, but also how fast it can respond to stimuli. They're employed in the manufacturing, telecommunications, health, transportation, and numerous other industries. And the two types of real-time systems are soft real-time systems and hard real-time systems. So soft real-time systems are those where they can actually miss a deadline and it's not catastrophic. An example is Netflix, so that's a real-time system, and if it misses a deadline of serving up a video, then you drop a few frames, or worst case, your video crashes, which isn't catastrophic. It's not going to endanger life or anything like that. And then a hard real-time system, it needs to complete every required task by its deadline, otherwise something terrible could happen. And an example of that, if you can see that tiny photo right there, is an airbag system in a car. So it senses that impact and immediately deploys an airbag, and it can't miss that deadline, otherwise people could get hurt. Our next topic is what actually constitutes the Linux operating system. And it's an operating system derived from the Unix operating system with many different flavors and functions, and it's a general purpose OS, at least in its base form. The Linux kernel was created by Linus Torvalds, and Linux is an open source operating system, much like Unix and the many flavors that come along with it. And then our next slide is what are some common flavors of Linux. So there's Ubuntu, which is a desktop. It's primarily a desktop operating system. It can run on basically any computing platform, but most desktop operating systems with Linux use Ubuntu or some sort of Debian or Red Hat. Tails, which is right there, is a Linux operating system that's optimized for privacy. It's part of the whole Tor network kind of thing, so it's meant to emphasize privacy over everything else. And like I said previously, there are many, many, many other types of Linux available also. So getting into the meat of the presentation, the means of implementing Linux as a real-time operating system. So there are three main means of doing this. There's one that uses a thin kernel, one that uses a nano kernel, and one that uses a resource kernel. And then a fourth sort of variety or variance of that is using the Linux kernel itself and just optimizing it with full preemption. So a thin kernel is one where the kernel, there's only one other kernel, so you have your original Linux kernel, and then you have a thin kernel that sits right above the hardware layer, and that actually allows for the better handling of interrupts and things like that. So an advantage of that is that it's excellent at handling interrupts. Disadvantages are that debugging is a real task because the user tasks and then your real-time tasks are actually completely separate. So it's really hard to do a trace on which is actually causing your bugs. The nano kernel is a means of it's a means of creating a hardware abstraction layer. So you can actually have multiple operating systems and multiple kernels, multiple nano kernels running at the same time. And the benefit of that is you can run multiple operating systems and multiple high-level operating systems at the same time as running a real-time operating system with Linux. And then the resource kernel, which is our third variety, is mainly used with it's actually appending a module to the original Linux 2.6 kernel. So it's basically the least modified Linux kernel from stock of all of these. The thin kernel and the nano kernel actually create a completely different Linux kernel, and they append that to the Linux operating system. And then the resource kernel is just a small alteration to the Linux kernel, essentially. So in order of changes, there's the nano kernel, which actually creates multiple other kernels, the thin kernel, which is one other kernel attached to Linux, and then the resource kernel, which is a slight alteration off of the stock Linux kernel. And also the resource kernel utilizes reservations to system resources, so it can almost ensure that every task that it performs has full access to the system for resources. as opposed to a disadvantage of the thin kernel, which is that because it's a thin kernel, you don't get full access to all system resources all the time. And then the Linux 2.6 kernel, it can be used for soft real-time operating system tasks. Like I said before, those tasks where it doesn't have to meet every single deadline 100% of the time. And it can actually be the stock kernel can be transformed into a hard real-time operating system through the use of a patch. And a common one of these is called the preempt RT patch. And then on this slide right here, you actually see diagrams showing the actual outlines of each kernel that I described. So the resource kernel, as you can see, it's right there. Excuse me, sorry, sorry for the interruption. So as you can see with the resource kernel, which is right there, it actually shares its space with the Linux kernel, and that kind of, shows in a graphical means that the resource kernel actually just adds a small bit of code to the original Linux kernel. The nano kernel, as you can see right here, actually has, this one only has 3 separate ones, but you could have many more than that. It has your hardware abstraction layer, and then you have kernel, kernel, and kernel, which, definitely shows that you can have multiple operating systems running along with your real-time system. And then you have your thin kernel, which actually just has a completely separate kernel right above the operating system layer, right above your hardware layer. And that's the kernel that you're appending to Linux's original kernel itself. And then our next slide is what are the common real-time Linux flavors? And then I guess going back to what I said previously, there are 3 main means of doing this. You have a patch, you have a resource kernel, a nano kernel, and a thin kernel. So 4 means of doing that. And so preempt RT, which I was just talking about, is actually a patch. The Linux/RT is a resource kernel. RTOS, which is a nano kernel. RTAI, which is a thin kernel, and ZenMI, which is another thin kernel. So a thin kernel is actually the most popular means of implementing Linux as a real-time operating system, and that's followed by resource kernels and nano kernels. And the patch method is actually the least common because it's the least developed. And then on this last slide right here, you have the advantages and disadvantages of using Linux in a real-time system. So advantages is Linux is open source, it's stable, it supports multiple processors, it's adaptable, and it has hard and soft real-time operating system options. You can select either or depending on your needs. Disadvantages, the kernel and the OS itself must be modified. So like I was saying before, the least modified version of this is either the resource kernel or a patch, and ranging to the most modified, which is creating a completely new kernel, which kind of appends itself to the Linux platform, which is a thin kernel or a nano kernel. And also the real-time system and the user system can't communicate in real time. This is for patched operating systems. So for the last 3 factors in this, these are all for patched kernels. So the real-time system and the user system can't communicate in real time. Linux is slowed by its real-time tasks, and you can't share drivers between the real-time system and the patched user system. And that's it. So I guess in summary, Linux is a great operating system to use for real-time systems. You have 4 main means of doing this. You can use the original operating system's kernel with a few small tweaks to get soft real-time performance out of it. To get hard-time performance, you either have to patch it or implement a completely new kernel, which we saw with thin, nano kernels, and resource-based kernels. And then we went over the types of Linux, what actually constitutes a real-time system, and the advantages and disadvantages of using Linux as a real-time system. And as you can see, Linux has far more advantages than disadvantages for this application. Thank you.